Today, we are embarking on a journey to confront one of the most mysterious, awe-inspiring, and almost unsettling forces in the entire observable universe, the Great Attractor, an invisible cosmic beast that has been silently tugging our entire Milky Way, our neighboring galaxies, and hundreds of thousands of other star systems across hundreds of millions of light-years toward a single hidden point in space. For decades, this titanic gravitational anomaly remained hidden from our view, masked by the very galaxy we call home, and its discovery completely rewrote our understanding of how the largest structures in the cosmos move, interact, and evolve. Most people imagine our galaxy floating calmly in the blackness of space, spinning gently as stars orbit its core. But the truth is, far more dramatic. Our Milky Way is not still. It is racing through the cosmos at nearly 600 kilometers every single second, more than 2 million kilometers per hour, carrying our Sun, our Earth, and every living thing on our planet, along for a ride we cannot feel, cannot see, and only recently began to understand. This is not random motion. This is not the gentle drift of cosmic expansion. This is a relentless, unyielding pull from a gravitational source, so massive that it dominates the motion of an entire supercluster of galaxies. Today, we will dive deep into the story of how we found this hidden beast, why it took us so long to see it, what it actually is, how it shapes our cosmic fate, and the mind-bending questions it still leaves unanswered about the structure, gravity, and future of our universe. Let us start with the moment everything changed. For most of the 20th century, astronomers operated under a fairly straightforward model of the universe. The cosmos was expanding uniformly after the Big Bang, and galaxies moved apart from one another in a predictable pattern called the Hubble flow. Galaxies had their own small motions within groups or clusters, but nothing that would disrupt the overall expansion. That all began to shift in the early 1970s, when the first hints of a gravitational disturbance appeared. In 1973, and again in 1978, astronomers noticed something deeply odd. The Milky Way's motion relative to the cosmic microwave background, the faint afterglow of the Big Bang, showed a clear dipole pattern. One side of the sky, slightly warmer, the other slightly cooler, that revealed our galaxy was moving far faster than any known local gravity source could explain. The speed was off the charts, roughly 600 kilometers per second, toward a patch of sky in the constellations Centaurus and Norma, a direction that lay directly behind the dense, dusty disk of the Milky Way. This region became known as the zone of avoidance, a band of space where our own galaxy's gas dust and stars block nearly all visible light, making it impossible to see what lies beyond with traditional optical telescopes. Imagine trying to look at a distant lighthouse through a thick, foggy window. That was the challenge facing astronomers who wanted to solve the mystery of our galaxy's extreme motion. Then came the breakthrough. In 1986, a team of astronomers, later known for their meticulous mapping of galaxy motions, announced a revolutionary discovery: the abnormal motion of the Milky Way, our local group of galaxies, and thousands of nearby galaxies, was not random. Every single one of these systems was streaming toward the same hidden region in the zone of avoidance, a region that exerted a gravitational pull so strong it overcame the general expansion of the universe for hundreds of millions of light-years around it. They named this unseen gravitational core the Great Attractor. It was not a star, not a single galaxy, not even a supermassive black hole. It was a colossal, diffuse concentration of mass, a gravitational knot in the cosmic web that acted as the undisputed center of gravity for a vast swath of the universe. The news sent shockwaves through astrophysics. We had long known about galaxy clusters and superclusters, but nothing this massive, this influential, and this perfectly hidden had ever been detected. Overnight, the Great Attractor became one of the most compelling mysteries in modern astronomy, a puzzle that forced us to rethink how matter is distributed on the largest scales imaginable. For years after its discovery, the Great Attractor remained a ghost. We could measure its pull, we could map the motions of the galaxies it influenced, but we could not see it directly. The zone of avoidance kept its true form hidden, leaving scientists to guess at its composition, its exact mass, and its physical size. Early estimates were staggering. Astronomers calculated that the Great Attractor must have a mass equal to 3 to 5.4 quadrillion times the mass of our Sun, tens of thousands of times the mass of the entire Milky Way, to generate such a powerful gravitational pull. To put that in perspective, our galaxy has hundreds of billions of stars, but the Great Attractor's mass dwarfs everything we can see in our cosmic neighborhood. The question haunted researchers: if this thing is so massive, why can't we see it? Where is all that mass hiding? The answer began to unfold in the 1990s and 2000s as we turned to non-optical telescopes that could pierce the dusty veil of the zone of avoidance. X-ray telescopes, radio observatories, and infrared sensors do not rely on visible light, so they can detect high-energy radiation and cold matter that optical instruments miss entirely. One by one, these tools lifted the fog. What we found was extraordinary. At the heart of the Great Attractor lies the Norma Cluster, also catalogued as Abell 3627, a massive, dense cluster of thousands of old giant galaxies, many of which are colliding and merging, blasting out huge amounts of radio waves and X-rays as they interact. This cluster is the most visible anchor of the Great Attractor, but it is only part of the story. The Great Attractor is not just one cluster, it is a sprawling complex of galaxy clusters, galaxy groups, filamentary structures, and most critically enormous amounts of dark matter. Dark matter, as you may know, is the invisible form of matter that makes up about 85% of the universe's total mass. It does not emit, absorb, or reflect any light, so we can only detect it through its gravitational effects. The visible galaxies and gas in the Great Attractor region contribute only a small fraction of its total mass. The overwhelming majority comes from dark matter, which forms a massive invisible halo that binds the entire structure together and creates the irresistible gravitational pull that tugs our galaxy and millions of others toward it. This revelation was a game changer. The Great Attractor is not just a collection of galaxies, it is a manifestation of the cosmic web, the large-scale structure of the universe, shaped by dark matter's gravity, a node where countless cosmic filaments converge to create the most powerful gravitational center in our part of the cosmos. In 2014, scientists gave us a new framework to understand the Great Attractor's role. They defined the Laniakea Supercluster, our home supercluster, a vast cosmic home that spans more than 500 million light-years and contains roughly 100,000 galaxies, including the Milky Way. The name Laniakea comes from Hawaiian, meaning immense heaven, and it is perfectly fitting. And at the absolute gravitational center of Laniakea sits the Great Attractor. Every galaxy in Laniakea flows toward it like water flowing toward the center of a whirlpool, following the curves of space-time, shaped by the attractor's unimaginable mass. This means the Great Attractor is not just some random distant anomaly, it is the anchor of our entire cosmic neighborhood, the point around which the largest structure we belong to orbits and moves. It is the quiet master of our galaxy's journey through the universe. Naturally, one question burns in everyone's mind. If we are racing toward the Great Attractor at 600 kilometers per second, will we eventually crash into it? Will our galaxy be torn apart by this cosmic beast gravity? The answer is reassuring, and it reveals another epic battle in the cosmos, a tug-of-war between the Great Attractor's gravity and the force of cosmic expansion, driven by dark energy. Dark energy is the mysterious, repulsive force that makes the universe expand at an accelerating rate, and it dominates the cosmos on the largest scales. Right now, the Great Attractor's gravity is strong enough to overcome the expansion in our local region, pulling us closer. But dark energy's push grows stronger as distances increase. Over cosmic time, billions and billions of years, the expansion of the universe will stretch the space between the Milky Way and the Great Attractor faster than our galaxy can fall toward it. We will continue to move in its direction, but we will never reach it. We will never collide with the Norma Cluster, never be swallowed by the attractor's dark matter halo. It is a cosmic chase, with no finish line, a dance between gravity and expansion that will play out for the rest of the universe's lifetime. This fact adds a layer of profound beauty to the Great Attractor story. It is a force that shapes our motion, but it will never destroy us. The study of the Great Attractor has also pushed the boundaries of our technology and our understanding. To map this hidden beast, astronomers have used flagship observatories like the Rosat X-ray satellite, the Meerkat radio telescope in South Africa, the Hubble Space Telescope, and now the James Webb Space Telescope, which can peer deeper into the zone of avoidance than any instrument before it. In recent years, surveys like Cosmic Flows 4 have measured the motions of more than 50,000 galaxies, refining our map of the Great Attractor's influence, and revealing small but puzzling discrepancies that suggest we may still not fully understand dark matter, gravity, or the distribution of mass in the universe. Every new observation brings us closer to solving the attractor's secrets, But every answer also raises new questions. How did such a massive gravitational node form in the early universe? What does it tell us about how the cosmic web grew after the Big Bang? Does it hold clues to the true nature of dark matter and dark energy, the two greatest mysteries in modern cosmology? These are not just academic questions, they are questions that touch the core of how we understand reality itself. When we look up at the night sky, we see stars, planets, and faint smudges of distant galaxies, but we do not see the invisible forces that govern the cosmos. The Great Attractor is a humbling reminder that the universe is full of hidden giants, forces so powerful they can move entire galaxies, yet remain unseen by our eyes. It teaches us that we are not stationary observers in the cosmos. We are travelers riding a galaxy that is being pulled by a cosmic beast we cannot see toward a destination we will never reach. It connects us to the largest scales of the universe, showing us that our tiny planet, our tiny star, our tiny galaxy are all part of a grand interconnected structure, shaped by gravity, dark matter, and the relentless expansion of space. The Great Attractor is not just a scientific curiosity. It is a symbol of the mystery and wonder that makes space exploration so deeply human. It pushes us to keep looking, keep questioning, keep building better telescopes, and keep reaching for the stars, even when the answers are hidden behind a veil of dust and darkness. We are lucky to live in an age where we can uncover these cosmic secrets. 100 years ago, we did not know that galaxies existed outside the Milky Way. 50 years ago, we had no idea that an invisible gravitational beast was pulling us through space. Today, we can name it, map it, and study it, and we will keep learning more about it in the years to come. The Great Attractor reminds us that the universe is far stranger, far more magnificent, and far more interconnected than we ever imagined. It is a story of discovery, of perseverance, of looking beyond what we can see to understand the forces that shape our reality. And as we continue to explore the cosmos, this invisible beast will remain one of the most fascinating chapters in our journey to understand where we come from, where we are going, and what lies beyond the stars. Please like, comment, share, and subscribe to the channel.